guys, welcome to Jane Academy. So this is our very first video on this channel, and so we're going to start with a very interesting topic in the physics and the portion that is circular motion. So basically these notes are from Sharma. I have just sorted the notes out which are important. So in this first video we will only discuss the basics of this chapter. We will cover angular variables, kinematical equations, tangential acceleration in tangential direction, which is tangential acceleration, and unit vectors along radial and tangential directions. Okay, so the basics. Angular variable. This is the most important part in this chapter. Okay, so basically starting with the first angular variable, which is angular velocity. So what is angular velocity? It's the rate of change of angular position. Okay, this is known as angular velocity. So the rate of change of angular position here will be d theta by dt. This is the rate of change of angular position, and this will be is equal to angular velocity, which will be denoted by omega. This is omega, not w. It's omega. It is angular velocity. Okay, so this is the angular velocity. Further, moving to angular acceleration. The rate of change of angular velocity is known as angular acceleration. Basically, the rate of change of angular velocity. In the kinematics, we used to do dv by dt, the rate of change of velocity divided by the rate of change of velocity. But here, as it is the circular motion, angular acceleration will be rate of change of angular velocity. Okay, so alpha is the symbol of angular acceleration. Angular acceleration will be denoted by alpha. It is equal to d omega by dt. Okay, it will be rate of change of angular velocity one time, and this is further equal to the double derivative of angular velocity, which is d squared theta upon dt squared. This is double derivative of angular velocity. Okay, so this was about the angular variables. Further, moving to kinematical equations. So these equations will be only considered true if acceleration is constant. Okay, so when the acceleration is uniform. Okay, the first equation is theta is equal to omega naught t plus half alpha t squared. So you can relate this directly with the equation s is equal to ut plus half t squared. As this is the circular motion, s here will be the theta, as theta is angular position. Here we discussed that. So here omega naught is the initial velocity. Okay, alpha is the angular acceleration, and t squared is the time taken. Here also t. So this was about the first equation. Second equation is omega is equal to omega naught plus alpha t. You can directly relate it to v is equal to u plus at. It is the first equation of kinematics. Okay, so omega here is the final velocity, omega naught is the initial velocity, alpha angular acceleration, t time taken. And the third equation is omega square is equal to omega naught square plus 2 alpha theta. You can directly relate this also with v square is equal to u square plus 2as. Omega square is the square of final velocity, and omega naught square is the square of initial velocity. Okay, and alpha is angular acceleration, theta is angular position. I think this is clear. Further, moving to the next topic, which is it's the linear distance traveled. So the linear distance traveled will here be noted with delta s. It is equal to r delta theta. R is equal to radius, delta theta is change in angular position we discussed earlier. So further dividing it by delta t on both the sides, we will get delta s by delta t is equal to r delta theta by delta t. Okay, so you don't need to remember this, you have to remember this and this. So talking about this equation, here v is linear speed, the linear speed with which the particle will be performing the circular motion. R is the radius of the circular motion. Okay, omega is the angular velocity. Then the next topic is tangential acceleration, AT. It is referred to as the component of acceleration along tangential direction. The acceleration in the tangential direction of the circular motion is referred to as tangential acceleration. AT is the AT is the symbol for tangential acceleration, is equal to dv by dt, and which is further equal to r d omega by dt. d omega by dt is change in angular velocity, the rate of change of angular velocity. AT is angular acceleration. so which can be further written as AT is equal to R alpha. Alpha is angular acceleration. We studied here that alpha is equal to d omega by dt. So the same is applied here. Alpha t, AT is equal to R alpha. Alpha is replaced by d omega by dt is replaced by alpha. So this was about tangential acceleration. Similarly will be the case of radial acceleration. Okay, moving further, the next and last topic of this video is unit vectors along the radius and tangent. So that, can you see this figure? So here OY and OX are the axes, so are the x dash and y dash. So here PA is the unit vector along radial direction ER, and PB is unit vector along tangential direction, it is denoted by ET. So here ET is PA, it is the unit vector along tangential direction. ER is PB, unit vector along radial direction. Okay, so PA will be the components of the PA will be added here. From this figure we will just take the components out and we will add them. So PA, this is PA, it will be I cos theta, the x-axis, I cos theta plus j sin theta. Theta is here, same will be the theta here according to the corresponding angles. So this is also theta. Okay, so here this will be the unit vector along radial direction. I and j are the unit vectors along x and y axis. Similarly, moving further to PB. So you guys might think that why PB is equal to I minus I PB sin theta plus j PB cos theta. So why there is a minus I here? See figure carefully. PB is here. So x dash, when we extend this right here, it will be minus x dash, and so the x-axis component will be negative. And so it is written as PB is equal to minus I PB sin theta plus j PB cos theta. This can be replaced by ET, which is the unit vector along tangential direction, is equal to minus I sin theta plus j cos theta. Okay, so this is the end of this video. This had the basics of this chapter, and this is the part 1. More parts coming. Please hit the subscribe button and like the video if you like it. Share it with your friends so that they could also score good in their exams. So this is the basics. You can anytime revise this. And these formulas which I have highlighted from the green color are important and needed to be remember. Along the video, please note down these formulas and note down these notes. Very helpful. Okay. So thank you and see you guys in part 2. Please be with us.